Hi, this is Calvin Liu, and I'm here to talk about GPS. I'm using here my cell phone, which is an EVO, and you can see from the top with the blinking satellite symbol that the GPS is on. Now, we all think GPS is very accurate, but the reality is unfortunately not correct. If you'll notice right now, even as I'm talking without even touching the phone, my location is shifting simply due to radio signals changing. If I actually move the phone, we get different results. So you can see that the positioning of the phone actually affects the GPS quality to a significant extent. Part of this is due to the hardware. There are, however, different ways and better hardware to make this better. Up here we have a Surfstar 4. We'll use this as one test vehicle, and here we're using a MediaTek chipset, which Parkit has created. With the Surfstar 4, it doesn't talk to my phone directly, but we can see what kind of difference, specifically the number of satellites it can access. Now notice here that there are 11 possible satellites in this hemisphere. The Surfstar 4 uses only the US satellite systems, and so this is actually a pretty good result. It's a pretty high sensitivity chipset, and so has pretty good accuracy and can access a reasonable number of satellites. I'm also on a 10th story of a building, and so we probably are accessing more satellites than would normally be accessible. The Parkit chipset, however, accesses all of the other satellite systems in addition to the US. The feed is the same. You can see up here, this is the NEMA feed coming out of the Surfstar 4. This is the same feed that we get from the MediaTek chipset. So coming back to the phone again. So notice here the blinking blue light. What I'm going to do is essentially connect GPS via this app, and you'll see this light go solid. So with the 8 satellites that we see with the Surfstar 4, we're actually getting 10 or 11, we'll probably end up with 12, using the MediaTek device. The MediaTek device is a lot faster lock time. Because it accesses more satellites, it's going to be more accurate as well. We'll see this when I go outside for the second test. But essentially, this app also overrides the GPS position, so that if I go back into Google Maps, which I demonstrated originally, you'll notice now that the location is actually correct. Before it was wrong side of the street, it was drifting around, etc., etc. Now we don't have this problem anymore. Even if I place the phone down again, as per the original example, we don't see changes. I can shift around the actual device. Minimal effect. This is what happens when you have a much better GPS chipset. This, of course, is being done from my living room, so it's a somewhat extreme example, but I'm going to go on the street and show you what the actual street performance is like now.